Hello everyone and welcome. Today we're looking at valence versus valence electrons, and this is presented by Science Visualized. Valence basically refers to the number of bonds, so number of bonds formed by an atom, while valence electrons refers to the number of electrons on the outer energy level. For example, oxygen is in group 6, so we say 6A. That means it has 6 electrons in the outer energy level. So we'll say its valence. So valence electron for oxygen equals to 6. But the number of bonds formed by oxygen is determined by how many electrons are required to form an octet. Octet rule basically states that atoms attain stability when they have 8 electrons on the outer energy level. So looking at oxygen, we have 6 electrons, and therefore we are missing 8 minus 6, which equals to 2 electrons. So that means oxygen will form 2 bonds, and therefore it has a valence. So valence equals to 2. Another example will be hydrogen. It's in group 1A, and because it's in group 1A, we use another rule. Instead of octet, we have another one called duplet, which states that there is some stability when you have 2 electrons on the outer energy level. And therefore, looking at hydrogen, in group 1A, it has 1 electron. So that means we're missing 1 more electron to form 2 electrons. So 2 minus 1 equals to 1, and therefore that means hydrogen has a valence of 1. That means it makes 1 bond. For hydrogen, it's in group 1. The number of electrons on the outer energy level equals to 1. You'll quickly realize that group numbers correspond to valence electrons. I'll quickly make a table here. So I'll say group number 1, 2, 3, 4, 5, 6, 7, and 8. And group number 8 is very stable, and that's why they're called inert gases, because they don't react. They already have 8 electrons, but in the case of helium, helium is in group number 8, but it has 2 electrons in the outer energy level. So that one satisfies the duplet rule for 2 electrons. So only helium and hydrogen will need 2 electrons for stability. The rest of the atoms in the periodic table, we will use the octet rule, 8 electrons. Now let's continue with the table. So the second row is valence electrons. Valence electrons corresponds to the group number. So group number 1, valence electron of 1. Number 2 is 2, 3, 4, 5, 6, 7, and 8. Next is valence. And valence refers to the number of bonds required by an atom to become stable. In other words, how many electrons does it need to attain stability? Now, it's very interesting when you look at group number 1 to group number 3. Those are called metals because they're on the left side of the periodic table. And then starting from group number 4 or 5, depending on which atoms you're looking at, those ones are non-metals. So generally, metals will have a positive charge, while non-metals will have a negative charge, except group number 4, and you'll see the reason for that. Okay, let's go ahead with the third row for valence. Valence here refers to how many electrons are required to attain stability. If you write an electron configuration for group number 1, let's say, for example, sodium has electrons 11. It will be 1s2, 2s2, 2p6, 3s1. If you count the number of electrons, so that's 4 plus 6, that's 10 plus 1 becomes 11. We have accounted for 11 electrons, but you will see that 3s is a new shell. The outer shell has only 1 electron. So group number 1 has 1 electron in the outer energy level. But how many bonds does it form? Now, look at this outer energy level. It has only 1 electron, and we have 2 options. Either we add 7 electrons to become 8 for octet rule, or The other option will be to lose, so -1. If we lose this one electron, then we revert back to this state. So that energy level, the lower energy level, which actually has 8 electrons, that's already filled. You'll see that metals will rather lose 1 electron than gain 7 electrons. And because they're losing 1 electron, they end up with a positive charge. So because they lose 1 electron and end up with a +1 charge, they have a valence of 1. So we'll say has a valence of 1, and they have a charge of +1. Group 2 will rather lose 2 electrons, so they have a valence of 2 and a charge of +2. Group 3 has a valence of 3 because they will lose 3 electrons, and because of that, they will end up with a charge of +3. Now, when we look at group 4, this is very interesting because 4 is halfway. They can either lose 4 electrons or gain 4 electrons to get to 8. And both of those require the same amount of energy. And because of that, 4 will rather participate in electron sharing than in forming ions. And because of that, group 4, like carbon and silicon, will mostly form covalent bonds, because they will prefer to share electrons than to lose or gain electrons. And because of that, they generally don't form charged species, so there is no charge. But because they will form bonds, they will still need to share with 4 other atoms because they need to get to 8, so they still have a valence of 4. Next is group 5a has 5 electrons. We're only lacking 3 to form an octet. And because of that, it will just form 3 bonds. So it has a valence of 3, and that's because it will accept 3 electrons. And because it accepts 3 electrons, you end up with an extra 3 electrons. Each electron is a -1 charge, and you end up with a charge of -3. Nitrogen and phosphorus, they form -3. Group 6a, like that will be oxygen and sulfur. They have 6 electrons on the outer energy level, so a valence electron of 6. That means they are only lacking 2 electrons. Therefore, they will form 2 bonds, so they have a valence of 2. And because they accept 2 electrons, they end up with a charge of -2. Group 7a only needs 1 more electron, so it has a valence of 1, and then a charge of -1. Group 8 is already satisfied, so we don't talk about it forming bonds, and also no charges. Please consider subscribing if you enjoyed this presentation.